Yeah, today I will be discussing about the columns. So columns is one of the important part in the HPLC system. So where the separation usually takes place. So it is considered as one of the important part in HPLC system. So the columns variation, as you all already know about the term, what is the HPLC. So it's a very in the natural technique where you can see the separations can be done by using the different principles, and I don't want to elaborate upon that on HPLC because it is system. So today we'll see the column. So as I told earlier, so it is considered as the heart of the HPLC where separation occurs. So in order to undergo this separation, so the column material plays a very important role. So it may be of stainless steel for high pressure resistance, and it can be used as a glass, or it may be polyether ketone. So when it comes to the stainless steel, column should have a withdraw capacity of 8000 psi, and the dimensions usually analytical column varies with the 15 to 250 mm and internal diameter 1.2 to 46 point. In case of preparatory column, it is 50 to 250 mm internal and internal diameter 4.6. So the main advantage of HPLC, as you all aware, is the resolution. So resolution plays a very important role, and particularly when you see the column length. So longer columns usually are used to increase the resolution. So shorter columns used for the shorter analysis time. So this avoids the back pressure, and there will be usage of less solvent also. The column internal diameter usually greater sample loading, so narrow columns for the more sensitivity. And particle size also, spherical for lower pressure and efficacy, and the other parameters which are used to the separation techniques in order to maintain the resolution in case of HPLC. Sometimes you need to use inline filters, so they are merely fitted in between the injection valve and the column. So these particularly which will allow which will streamline the flow pathway, and it minimizes the peak disturbance, and usually sometimes in case of man loading or even in peak desorption. So there are two types. So one is the stainless steel, as I told earlier, and metal bore bicompatible. And another important aspect in case of column is you need to go for the guard column. So guard column which protects the column from the contaminants and extends your lifetime. That is very important because columns is a little bit costlier part in the HPLC. So you need to take care of this one. So guard column is a must. And it not only protects the column for the clogging without altering chromatographic results, such as particularly with respect to resolution, and sometimes there may be decrease baseline drift. So that is the importance of the guard column. So the contaminants are retained at a 4 mm dispersible cartridge. So the display shows the different guard columns, and column heater, whenever you have to maintain the temperature at that time, you need to maintain the temperature of the columns, which are usually set by to improve the efficacy and analyte quantification, so which increases the speed of analysis, because sometimes since mobile phase velocities may be decreased with increase in the temperature. So column over design, so usually it contains block heater, air bath, and different types of filters. And fittings also plays a very important role in column. So column sealing plugs usually seal columns for the storage. So column coupler is also used, couple several columns together. So you have to maintain the separation efficacy, no influence on the back pressure. So fused silica capillary adapter is also used, and sometimes you can use the back pressure things also. So the specifications, usually the columns can be classified mainly based upon the molecular weight, separation mode, and based upon the pH or whatever using, and even sometimes it can be classified on the application base or even on the different types are used. So based upon the molecular weight, you can just select the different columns, and there are different types of column. One is capillary, microbore, analytical, semi-preparative, and preparatory columns. So there is a recent development in this analytical technique. Is there a stationary phase hydrophilic interaction liquid chromatography analytes elute in order to increase the polarity. So you have to, there is a advantage of having the latest versions of the analytical column. So polymetric stationary phase can also be increased by stability of pH. Then sometimes monolithic stationary phase, highly porous particles. So high mobile phase and rate low pressure is also used. So particles in packing material, usually greater column capacity, allowing the injection of larger sample weight, which have a diameter of 1.5 to 5 micron in the range. So this is the figure represents where the arrangements of the porous materials, and pellicule particles are also used, which consists of the solid spheres that are covered with a very thin surface layer of the stationary phase. So usually varies with a diameter 1 to 1.5, which have got a low surface area and reduced retention time. So particularly used for the separation of the, when you go for the large biomolecular molecules. And superficially porous materials are also sometimes used, which is gives your longer retention time, and porous layer provides the faster separation techniques. So other inorganic particles which you can use in the case of the packing the column is zirconia, alumina and titania, and graphited carbon are also sometimes used. So latest is the UPLC columns, which increases the resolution and compared to the normal HPLC. And not only resolution, high speed can be increased, and the sensitivity is increased in the liquid chromatography. Here is a slide. What you are seeing is there is some slight difference between the HPLC column and the UPLC column. When you use a C18 column with a diameter of 4.5 in case of HPLC, then in case of UPLC it is used C18. It is having only 50 into 2.1 mm in diameter. So particle size 4 micrometer particles, and here in case of UPLC it is 1.7. Then flow rate usually 3 ml per minute is required in case of HPLC, whereas in case of UPLC you can see it is a 0.6 ml per minute. Then injection volume, as you are aware, that 20 microliters, but here in case of UPLC it is 3 microliter for portal size, and sometimes it varies the 5 microliter also. And very important is the total run point. Suppose if you give a total run point of 10 minutes in case of HPLC, so the same method when you apply it to the UPLC, it takes only 1.5 minutes. And theoretical plate count 2000 in case of HPLC, and it can be increased in case of 7.5. So there is regeneration also can be done in case of the column. Then finally what I want to conclude is the suppose maintenance of the column and maintaining proper storage and all these things will give a important aspects in case of HPLC, where you can do the lot of work. And as I discussed the UPLC, so latest technology have come, so column plays a very important role. Thank you.